One of the cool things about most of the transforms in Nuke is that they're reversible. So not only can this corner pin be used to transform or corner pin something to follow something else, it can be used to uncorner pin something. So let's take this corner pin and duplicate it. I'm going to copy one and paste it here, and now you'll notice it's the same expression link. And I'm going to connect it to the plate, the background plate. You'll notice that it has an invert button. This will invert the meaning of all of these corner pin motions. So if I check that off and I view here, we hide this, you'll notice the effect is that the plate is actually stabilized around the tracks that I've corner pinned. Rather than following the phone, it is now pinning down the phone to my reference frame. Now this is actually a great way to check the quality of the track. I know many compositors that use this very technique before ever going further in a motion tracked shot or a match move type shot to validate the quality of their track. This is looking pretty rock solid. If I hover my cursor over this, you can see these points aren't moving in the slightest. So that's a good track. Now that the image has been stabilized, we can work on it as if it was a still frame practically. So I'm going to introduce you to another node that we really haven't looked at much, which is the Roto Paint node. And to get that, you hit P. I've now dropped down to paint mode. Now it has most of the familiar tools that you're likely to see in a program like Photoshop, a clone tool, a paint tool, all these others. We're going to use the clone tool. To use the clone tool, you hold down Shift to change the size of the brush, and you hold down Control to define the area that you're cloning from, which is this area to the left of the cursor, and then the area that you're cloning to, which is the one that your main cursor hovers under. I'm going to attempt to clone the frame here over this marker. So I'm going to clone some of this frame up over that. Try to get a pretty reasonable, decent look. Yeah, that's okay. Let's do this one. Now, if you can't really see the viewer very well, you can always turn up the brightness. So I'm going to clone this over, and I will clone this over. Touch that up a little bit there. And clone here. I think I got a little bit too greedy on that one and cloned away. I'm hitting Control Z to undo. Fill this in here. There we go. That looks kind of like the corner of a screen. And clone this down here. Okay. Now by default, these paint strokes only last for one frame. So you'll see life, it says 1, which means frame 1. If I would like these to last for the entire duration of the shot, I can multi-select them all. So I'm shift-clicking here to select all of them. And I can go to the Lifetime tab and turn their lifetime from single frame to all frames. Now, this clone paint stroke, or paint strokes, will repeat for every single frame. So let's look at that. If I toggle forward or frame forward, you can see the paint stroke is being repeated for every single frame. It's doing a pretty good job of hiding those. So we've painted out the tracking markers, but you know what? The producers just called us and they told us that we can't get the rights to the Samsung brand. So while we're in here, let's fix that too. We're going to use a different technique for this. Rather than using the paint tool to paint it out, we're going to take a little patch of the background and scoot it over to change the Samsung logo to something a little different. To do that, I'm going to use a tool called Transform Masked. Now the transform masked tool requires an input, and it also requires a matte. So just like every transform, it requires the image that you want to transform, but it also takes a mask, which will be the thing that we're transforming inside of. So to generate that mask, we're going to just use another roto node. And I'm going to very quickly draw a mask around the area that I want to cover with the thing that I transform. Connect that to my transform masked, and instead of doing all channels, I'm just going to do the RGBA because that's all I'm really interested in. And to make this a little bit easier to work in, I'm going to move the pivot point of the transform by holding down Control and dragging it to where I would like the pivot point to be. So since I have a couple of S's here, let's say I'm going to copy that S over that S. So let me move the pivot point to a place where I can use a landmark on the S, say the corner here of that S, and I'll drag that over that S there. Now when I view at the transform mask node, you can see I've scooted the image over inside that mask and duplicated Sam's to make the Samsung logo say Sam's. So we now have our slick Sam's phone. And because it's copying this per frame, it's picking up the same exact motion blur that is baked into the plate as it goes. So it looks pretty slick. And because we got such a solid track, it looks really solid as well. It doesn't seem to swim around or slip. And even if this track wasn't as rock solid, because the thing that I'm copying would move the same amount as where I'm copying it to, this wouldn't seem to slip very much in any case. So this is a great way of patching things up using this technique, because even when there is a slight misregistration or an imperfect track, you're copying the motion over again anyway. Okay, so I've got my paint fixes all done. My Sam's phone and my tracking markers painted out. Now we need to get this back so that it's moving again like the original plate. We already did a corner pin with an invert enabled to stabilize it. We can just as easily uninvert it or put the motion back in to make it move again. So I duplicated the corner pin, and it's still got its original expression link. And I'm going to turn off invert in this one, and this should make it move just like the original plate did. And that's great, except for if we compare this to the original plate, I'm going to put the original plate on the 1 view, 1, and I'm going to put my rematch moved plate back onto the 2 view, and I toggle between the two. You'll see that there's obviously some kind of filtering going on. So even though these transforms are technically concatenatable, in this particular case, because I have nodes in between them, I'm losing the ability to concatenate these transforms. So I can't simply reverse my motion and use this as my background plate. There's an additional problem as well. You'll notice that I'm getting some cracks and stuff in the plate because the canvas is getting clipped off somewhere in this logic. But that doesn't really matter. I can't use the whole plate anyway. Really what I'm interested in is my paint fixes that I've added. So if only there was a way where I could use a mat to cut out the paint fixes only and stick them back on top of the original plate. I'll bet there's a way we can do that. So how we're going to do it is we're going to get the alpha channels for all of these edits that we've created, and then we'll put them back through the corner pin, and then we'll use those alpha channels to cut out our paint fixes and stick them back over the original plate. So let's see. Easiest way to do that, to get this alpha channel, this mat that we've created would probably be to just copy it straight in. So I'm going to use a node called copy. The hotkey for it is K. This will copy a channel from the A input into the B input. So I'm going to use it to copy the alpha over. That's what it does by default. You can copy as many as 4 channels. So now if we view here at the copy node, putting that on the one view and toggling alpha, you can see it's copying in the alpha channel from the roto shape into this stream. I also need to get the alpha channels for the tracker marks. Now this is an excellent opportunity to use a procedural method for extracting those marks. Also, because they're static in frame, I could just draw a couple more roto shapes if I wanted to do that, because they're completely static. But rather than do that, let's build them procedurally. Let's extract a mat using the brightness of the image itself. You'll notice that the tracking markers are the brightest things in the frame. So we can use a keyer type called a luma key. The node for it is called keyer in Nuke, to extract a mat from those. So I'm going to just tap my node graph here above any other work that I've done, but after where I've stabilized it. And I'm going to start making a key. By default, it is set to luma key, which means it's using the brightness of the image to generate a key or an alpha channel. We're going to view the alpha channel here by hitting A here. And you'll see that by adjusting the controls, I can generate a mat. Now, luma keys are one of the simplest types of keys you can produce, but they happen to be extremely versatile. They're probably one of the more powerful keyer types that compositors use all the time, even in conjunction with more sophisticated keying types like color keyers, which we're going to look at later in the term. But as you can see, just from something as simple as the brightness of the image, I'm able to create a pretty usable mat. I'm getting a bunch of other contamination, though, that I don't really want. So let's look at a strategy to get rid of that. If you look closely, you'll see that the tracking markers do fall into a nice box here. This is an excellent opportunity to use what is called a garbage mat, which is a very simple roto shape that trims off the junk that you don't want. That's why it's called a garbage mat. So I'm going to drop down another roto node using the O hotkey. And I'm just going to put it directly underneath the luma keyer. And I'll start drawing out a very simple shape that captures the stuff I'm interested in. You'll notice that by default, the roto node has created a solid white alpha, but it's really versatile. It can do all kinds of other things. For example, I can negate this, and I can make this shape a different color if I like also. So the first thing I'm going to do is I'm going to reverse the meaning of this shape. I'm going to say make everything outside what I want, and you do that with this checkbox here by clicking it. Now it's saying everything outside of the shape is what I want you to paint. And then instead of making it white, I'm going to make it black. So I'm clicking the color swatch here to change the color of the roto shape. So I'm going to just make the alpha channel that it's feeding out black. So now what my roto shape is doing is everything outside the shape is being painted black, and it's covering all of my garbage. So I use this to very quickly garbage mat out, or G-mat out, these details I didn't want after my key. I'm going to tighten it up just a little bit, and that should get everything I need. Now I need to get this alpha channel combined with the other one that I already copied in. Now, alpha channels are images just like any other. So all of the compositing logic that you could use to combine regular images together, say using an alpha channel or a matless merge node, you can use on alpha channels as well. So I have that alpha channel and this alpha channel that I need to combine. Because this area is completely black, I could combine them by simply adding them together, or I could use another operation like a max, which would take the brightest pixel of either one of these and output the brightest of either. Hitting tab and typing max, drop down a max, and connect it to the two. And you can see it's taken the maximum of the pixels from either input and passed them through the max node or the merge node. Let's look at the RGB channel though. You'll see, unfortunately, it's also done the same with the RGB images. It's taken the maximum of those two and combined them as well. So what I need to do is constrain this merge node so that it does not max the RGB channels and only maxes the alpha channels. So if I go to the merge node here, I can start turning off the channels I don't want to merge, and now it's only affecting the alpha channel. It's taking the max of the alpha channels of the two and the A input. We'll wire that into the rest of our comp, and we're ready to keep going. Now the corner pin is pushing along both the RGB and the alpha channel. I'm going to turn on the matte overlay mode by hitting M, and you can see the alpha channels that we've embedded getting pushed along. Now it's just a simple matter of merging this over the original image that we created, but before our merge of the screen. So if you remember, the merge node that expects an unpremultiplied input like this is the matte operation. So I'm going to type tab, start typing out matte to get a matte merge, A over B, and I've filled in my paint fix over my original plate. So now the only thing getting that filter hit is the paint fix, but you'll see there's still a problem. My mats for my little tracking markers aren't quite big enough to completely cover them, so let's manipulate that mat a little bit. The erode dilate neighborhood operation is excellent for growing and shrinking mats. It's we don't want to affect everything, so let's select alpha channel here so that we're only eroding and dilating the alpha channel. So now I can grow or shrink the mat that I've generated for the tracking markers here. And I only want to grow it enough to get the job done, because if you remember, my paint job really wasn't very good, so I only want to pull through the minimum amount necessary to get the job done here. That looks pretty good. That fixed it. Let's view it down here. Cool. Trackers are done. We got our Sam's logo fixed up. Tracking marker's gone. It's looking okay, but it probably still needs a little bit of work. Let's cover that in the next section.